Hey guys, before you take your lab check today, I just wanted to go over a couple things. So just as a refresher, divergent means that the plates are moving apart. You can see that with this arrow here. On your lab check, there might be images like this. It might have you identify that this is a mid-ocean ridge. Remember, the features that you can have is a rift valley where the land is ripping apart. And those are the main things you need to know about divergent boundary. Collision, you need to remember that collision is going to be forming mountains. It's two continents coming together. It's going to crumple the land between them, which is going to make mountains. And of course, your examples are over here, the Himalayan mountains, which are right there. You will have an image that's very similar to this. You need to be able to identify which one it is or which boundary it is. Here you have the Ring of Fire. Remember, the Ring of Fire is just a line of volcanoes that pretty much go the whole way around here. It's not a complete actual ring, but they call it the Ring of Fire because, volcanoes, fire, blah. Along this, wherever there's volcanoes, there will also be trenches. Remember, there's two features that you're going to get, trenches and volcanic mountains. And that is because of that plate subducting and melting and rising up there. And then your transform boundary, you need to be able to identify that they're sliding past each other and that you get earthquakes. On this web quest, you should definitely be aware of the types of boundaries, again, as well as where they form. You need to be able to identify where's the subduction zone on here, where's the trench, where's the volcano, for a subduction zone with volcanoes, okay? You definitely need to be able to identify that. Remember that at a collision zone, you're going to have mountains because continental crust and continental crust are the same density. There's not going to be any subduction there. All right, and then this is showing you a rift valley, how that forms, how it initially starts and then pulls apart. This is divergent to a T. This will eventually become a whole nother ocean, and in the middle here will be a mid-ocean ridge, like the Mid-Atlantic Ridge, where new crust is coming up and pushing away these two plates. All right, and then of course transform, they're sliding past each other and you get earthquakes. That's about it. There's no lifting or breaking down. When it comes to which of these shows a transform boundary, you are going to have to be able to identify which boundaries are transform and which ones are not. These all are showing that they're sliding, like I can't show you, but this is sliding this way, this is sliding this way. This background, this road used to be connected. This side slid this way, this side slid this way. This fence used to be connected. So this background piece moved to the right, this foreground piece moved to the left. This is just mountains, so this would be a convergent boundary. So you are going to have real life images. So like if I had to pull up a real life image for divergent boundaries, there's two that you should always be able to identify. Mid-ocean ridge. Images. Let me be more specific. Mid-Atlantic. All right, so the Mid-Atlantic ridge, you might see like a Google image like this, where it's showing you here is higher. That ridge is higher and then moving apart. And then the other place would be at the Red Sea. All right, so you have these two plates sliding away from each other. This will get broader. This is a rift zone. It's not a mid-ocean ridge yet because it's not an ocean. All right, but as it gets bigger, it'll eventually become an ocean. Is what it would look like in real life. So this is just a rift zone. The land is ripping apart there. Transform boundaries, you saw that on your actual web quest as an example of real life. And then we need convergent convergent collision boundary that we know is the Himalayas. So that's what it looks like in real life. You have this line, this line of mountains as these two plates run into each other. Subduction would be like Andes Mountains. All along here, you have this plate subducting in South America, creating volcanoes all along the edge here. Pretty cool. All right. And that stuff you can look at. You can look at that while you're taking your lab check. What I'm saying is, as you do your lab check, which is in the Friday 4.9 folder, this will be up at the top. You may use your plate tectonic organizer and the WebQuest, the two things I just briefly went over. All right, so use those. That's all you can use, and do your best on your lab check. All right, lab check's right there. Ready, go.